So let's see the division algorithm. So this is the formal version of something we have used since elementary school. So when we divide one integer by another, let's say by a positive integer, we get a quotient and a remainder, right? And so what this theorem says is that if you have an integer a and a positive integer d, then there exists unique integers q and r, and q is called the quotient and r is called the remainder, such that a is equal to d times the quotient plus the remainder. And the property, or a very important property, is that the remainder is in between 0 and d, right? And so let's see an example. So if we let a equal to 17 and d equal to 5, then 17 is going to be equal to 5 times 3 plus 2. And so here the quotient is going to be 3 and the remainder will be 2. And of course the remainder 2 is less or equal than 5. And so the division algorithm is important because it lets us, or I mean for many reasons, but one of them is that it lets us organize the integers by their remainders, right? So for example, when we divide by 5, every integer is going to have a remainder that is either 0, 1, 2, 3, or 4, right? And later, this is what's going to lead us to modular arithmetic. We're actually going to be looking at these remainders and going to be working with them. So instead of asking for the whole number, we often only ask for the remainder after division by some integer.